my Math 70s. I'm going to be going over a Centroid problem with you guys very shortly, just so you have the reference on where I'm getting this problem from. I made some extra problems to go over from 8.3, 9.1, and 9.3. They're in the file section in Canvas. If you go there, the problem I'm going to be covering right now is number 19. So it's this problem first. Find the centroid of the region in the first quadrant bound by the given curves. You have curve 1, y equals x to the fifth, and curve 2, x equals y to the fifth. So first one is y in terms of x, second one is x in terms of y. All right, so just a little recap from your 8.3 notes that I posted before. The equations we'll be looking at are located here. So essentially for your center of mass centroid stuff, the integrals you're going to need are right here. Let's see if I can draw that on here. Okay. So essentially these would be your moment equations. Remember, you can look for the derivation of the moments on WebAssign in chapter 8, 8.3. The equations you'll need though are right here. Okay. And then go ahead and clear that out. Also, if you look on the next page, you'll see your area formulas. Okay. So essentially right here, the one we'll be talking about is if you have an area between two functions, f and g. So I'll be rewriting all this on our whiteboard. So let me go ahead and stop sharing with you guys for 1 second. And then I'm gonna go to the whiteboard. Okay, a couple issues here, there we go. All right, still getting adjusted to this pin scenario here, but bear with me. So first thing is noting that for number 19, the equations we'll be using, we have our centroid at x bar, y bar, and x bar is defined as 1 divided by the area of the region times the integral from a to b of x times the difference of your functions, f of x and g of x, and then dx. Y bar is 1 over 2 times the area of the region times the integral from a to b. Now this one, you're going to make a big parenthesis and then a bracket. You're going to have f of x, the quantity squared, minus g of x, the quantity squared, and taking derivative. Sorry, taking integral, my bad, sorry. Put your dx at the end, okay? And then the last one, we don't have an area defined yet. So for your area, you can either use geometry for it if it's a nice enough curve, or if it isn't a geometric curve you're familiar with, you're going to be using the integral from a to b. And then you're going to have your function f minus your function g. And then put your dx on the end, okay? So these will be our equations that we need. Okay. All right, so then essentially we have two equations given to us. One, actually let's call it, equation little a. Let me erase these. Okay. So we're gonna have equation. I don't like that either. We'll just leave it off until we need to write it in there. Okay, so here's your first equation. You have a y equals x to the fifth. And then you have equation x equals y to the fifth. So we're going to need to graph this. And in order to do that, we're going to need to find the intercepts. We'll find where these equations intersect. Okay. All right. So first thing, doesn't matter which equation you use for this part, which variable you use for this part. You'll see in a second. So basically, if I want to use all x terms, for example, okay, from equation 2 here, I see that x is equal to y to the fifth. Well, we see that y from the first equation is x to the fifth. So we're going to have that part to the fifth as well. Okay, so to emphasize, different color here. So this part is the same as y. And that part is right there. Okay. All right, so let me go ahead and erase those. And then rewrite 5 in here. Okay, so we're going to solve this for x. Okay. So 0 equals x to the 25th minus x. Factor out an x. Oops. Oh, no. Still getting adjusted to this. Bear with me here. Okay. So let me try that step again. Let me factor my x out. I have x to the 24th minus 1 left over. And then I have from here 0 product property. X can either be 0 or x to the 24th minus 1 can be 0, which means x to the 24th is equal to 1. And then take your 24th root. And 24th root of 1 is still just 1. Okay. Now let me be more particular about that part actually, because since we have an even root, so if I take the 24th root of x to the 24th and the 24th root of 1, remember from here I get two different options. Because it's an even root, x is either positive 1 or x is negative 1. For number 19, we're asked for Q1 intersection. So for that, we're going to be using this x value. And of course, this x value. Okay, let me go ahead and save this part. And then I'm going to clear all the stuff on the bottom. All right, give me a second here. Just got this thing about 2 days ago, so I'm still getting adjusted to how it works. Okay, so now our next step is going to be to draw out what happens in between. So you might want to make a little table. Let's go ahead and just call this equation 1. I think we'll be able to follow. And then we'll call this equation 2. So let's start with 1. Notice if you have y equals a function of x, you're going to have x as your input and then y as your output. So we're going to cut, remember we had essentially x equaling 0 up to 1. So a is 0 and b is 1. So we can actually just cut that up into some little pieces, like between 0 and 1, take the average, and then take averages between those. So what we're going to get from that, we have 0, 1/4, which is 0.25, 1/2, which is 0.5, 0.75, and 1. And then we plug in and actually take these x values to the 5th power. So we're going to get 0 here and 1 here. In the middle, we're going to approximate these up to about 0.001. Oh, sorry. 0.0001. For 0.5, we get 0.03125. And when we plug in x with 0.75, we get 0.2373 for our y values. Okay, so what we're going to do, we're going to plot that first. Let's try to make a straight line here because that was real ugly. Okay, so we have 0 up to 1, and then there would be our half, 0.25, 0.75. That is so ugly. Try that one more time. Clearly I have no more motor skills for this. All right, I'm gonna just give up on that for right now. Okay, so what we'll do, we'll go ahead and just put 1 right at the top here. Remember, these are our y values, these are x. And then we're just plotting. So 0, 0 would be right here, and 1, 1 would be up here. We can even split on the y-axis this into some little pieces. So here would be your half, 3/4, 1/4. That's just so you can get a more clear view, but you'll start to notice how much you need to draw. Okay, so then we're saying, okay, x is 0.25, and then y is like super, super small. So somewhere along here. And then 0.5 for x. We get a little bit bigger, but still pretty small. And then for 0.75, we're going to get about right here. And came out a little bit ugly, but it should look kind of curved up like this. So that is equation 1. Okay. Now it kind of helps you for this particular problem. When you're trying to plot equation 2, just think, okay, well, now this thing is going to be wonky again. Okay, so we're saying now we'd want to put y in and get an x out for our output. So we're going to put y here and then put what x is equal to over here. But we're still going to plot traditionally with x on the horizontal and y on the vertical. So notice that we could use the same numbers in here. And we're going to get the same values out. So when we plot those, start at 0, 0. Now we're saying, okay, x would be 0.0001 when y is 0.25. So x is really small when y is 0.25. Okay, and then so on and so forth. So you'll get something that looks kind of like that. I would definitely suggest trying to draw these out so you can have a better idea of how smooth they should be. I'm just still working on this tablet thing right now, trying to figure it out. So thanks for being patient with me on this. Okay, so basically we're looking for the centroid of this region here. Okay. All right. So now the reason why this is so important, we need to figure out which is the top function. So, which one is function f of x and which one is function g of x. We're actually going to put both of these in terms of x so that we can use these values here, these equations up here. You could also take your integral with respect to y as well. You would just need to remember that you're looking at your y bounds and things now. If you guys want to see that one later, just let me know and I can go over it with you. Okay, so basically what we see for this one is that the top function should be equation 2. And we want it in terms of x. So what we're going to do, we're going to solve for y. We wind up getting that the 5th root of x is what y is equivalent to. So our function on the top, f of x, will be the 5th root of x. And then the bottom function that one is going to be equation 1. Also in terms of x. That one's already written the way it should be. So for equation 1, you have g of x equaling x to the 5th. Okay. Let me go ahead and clear this bottom part. No easy way to do so. I'm going to leave the graph here and the equation. All right. So just as a little bit of a recap, what we found out was that f of x is the 5th root of x, and g of x is x to the 5th. And our bounds 0 to 1. Okay. Now let me go ahead and get rid of the graph here. Okay, so let's start by finding A. As we saw, that wasn't a nice geometric shape. It kind of was like a weird little oval curve. So for the area, we have the bound 0 to 1. We're taking f of x, which is the 5th root of x, and we are subtracting g of x, which is x to the 5th. Don't forget your dx. So our area is equal to, we have the integral from 0 to 1. Remember, for this first part, your function f of x, you're going to have x to the 1/5. Subtract, you have x to the 5th. And then good notation would be to put parentheses around the whole thing and a dx, but you know, if you were to miss that in terms of writing on a homework assignment or something, I would just give you a notation about it, not mark it off completely. Okay, so then we should be familiar with how to integrate this. You have a power rule here. And then you want a coefficient of 1 in front, so reciprocal. And then here, you have a 1/6 in front. And that's from 0 to 1. We already know if you put 1 in here and 1 in here, you're going to get 5/6 minus 1/6. And then if you were to plug in 0, you'd get 0 minus 0. So you get 4/6 out of this, which is 2/3. That's just the area. It's the part we need for right here and right here in the centroid. So we're not actually done yet, okay? All right, let me go ahead and clear a few details. Let me put up here what our area is equal to. And clear all this. I must say this notepad thing is pretty awesome though. Having this before would have probably been a nice thing. All right, so now we need to find X bar. So X bar is equal to 1 divided by, you have your area, 2/3. And then multiply that by the integral from 0 to 1, x times, put your f of x first. That was the 5th root of x. And then you're subtracting g of x, which is x to the 5th. So in the front, you're going to get 3/2. You have 0 to 1. This is x times x to the 1/5 minus x to the 5th. That's 3/2. Integral 0 to 1. You have, remember this is x to the 1st times x to the 1/5. So you're going to get x to the 6/5 out. And then you have subtract x to the 6th. So 3/2. Integral 0 to 1. Actually, we can go ahead and take the integral. Remember, add 1 to this exponent. So you're going to get 11/5. And then you want 5/11 in the front minus x to the 7th, the 1/7 out in front. That's from 0 to 1. And then, of course, plug in and fiddle around with the fractions. You're going to get a 36 out of 77, which comes out to about 0.47. All right, and then let me go ahead and clear this out as well. Now we're going to want to find y bar, and we will have our centroid location. A little more. There we go. Okay, so back to draw. Find y bar. Y bar is equal to 1 divided by 2 times your area. Your area is 2/3. And then you're multiplying that by your integral from a to b. Now we have f of x. That is your 5th root of x. You're going to be squaring that. Subtract, you're going to have g of x, which is x to the 5th. You're also going to square that. So next step, we have 1 over 4/3. And multiply integral. Remember, this is x to the 1/5 squared. And over here, this is going to become x to the 10th. Next step, this becomes 3/4. We have 0 to 1 for our integral. This is x to the 2/5 minus x to the 10th. Take your integral to the 7/5. Now you have 5/7 in front, minus x to the 11th, 1 over 11 in front. It's taken from 0 to 1. Plug your bounds in and fiddle with the fractions. You actually get the same reduced fraction, which we found out was about 0.47. Okay. So let's go ahead and clear everything out here. Rewrite the numbers so we remember. Okay, so let's just draw like a quick sketch. Okay, that was ugly. Let's draw a quick sketch of what this is going to look like in Q1. So we had our top function. Looks something like this. Okay, not that. I'll put my n values here and try to meet. Okay. And then we had our bottom function. Looks something like this. So then what we found is that for our centroid, at x bar, y bar, we get 36 over 77, 36 over 77, which is about 0.47, 0.47 in terms of coordinate. Okay, so we would note that 0.5 would be right in the middle. 0.5 would be right in the middle. So our centroid would be located a little bit less, a little bit less. So 0.47, 0.47. Okay, so that covers the first example of when you have two functions that contain a region that you need to find the centroid for. I will give you guys another example in a little bit. So do hang tight while I review all these and make sure that they are golden enough to be put online for you. And I hope to see and hear from you guys very, very soon.